Chapter 3, Lessons 3 and 4 are going to be about slope-intercept form. Let's start off talking about the vocabulary for this lesson. First up is the slope-intercept form. That is this y equals mx plus b. The parts that we need to know for that are the m and the b. Y and x are always going to stay y and x. But we're going to be looking for the number that's in place of m, which is our slope. And you can see here, this is what we know about slope so far. And then our b is going to be a point called the y-intercept. The y-intercept is the point where our line crosses through the y-axis. So for example, if I were to have a graph, and this is my line, I'm looking for the point here. This is a y-intercept. We're going to talk about how to write an equation in slope-intercept form, how to put slope-intercept form on a graph. And to do that, let's look at these examples. For examples, I want you to see what steps we are going to follow. First, when trying to figure out anything with the slope-intercept form, we need to figure out what our b is, or our y-intercept. That's going to look like a point on the graph that is at 0, comma, and then some number. Whatever number that is here is going to be my y-intercept. Next, we'll find the slope, which we use in simplest form. We're going to leave that as a fraction or improper fraction. We're avoiding decimals unless we talk about money, and we're avoiding mixed numbers. Once we have those two pieces, we will be able to write the equation in slope-intercept form. Here we go. Our first example states the amount of money Robin earns while babysitting varies directly with the time as shown in the graph. Determine the amount that Robin earns per hour. So what we want to figure out here has to do with, we need to figure out what it means for her to earn money per hour. So let's figure out what's happening here. On this graph, I see that my line is crossing through the origin. That makes my b, my y-intercept, 0. And then we can figure out what the slope is, the rise and the run. Now, you guys are going to have to pick your own points on some of these. What I'm looking for are points on the graph where the grid lines cross. I'm looking for points that land here. On this graph, these are those points. We'll figure out the rise. I'm going to start here at this middle point, and I have to go up 1, 2, 3, but that's counting by tens. Actually, I apologize. That's not counting by tens. It's counting by fives. So from 15 up to 30, that's a positive 15. And then I will go from my ending point to the right 2 spaces, which will be plus 2 hours. So my slope is 15 over 2. And if I put this into my slope-intercept form, I'm going to replace the m and the b with those two pieces of information. B is 0, and m is 15 over 2. This gives me an equation of y equals 15 over 2x. Now, let's answer what the problem is asking. It's how much is she making per hour? Well, it looks like her per hour wages are going to be this 15 over 2. But let's go ahead and take the 15 over 2 and figure out what that is. That will be 7.5, which means she makes $7.50 each hour. The distance y in miles covered by a rabbit in x hours can be represented by the equation y equals 35x. The distance covered by a grizzly bear is shown in the graph. Which animal is faster? Explain. So that was a lot of information, but let's break down what it's asking. It is talking about a rabbit and a bear. It wants to know which one is faster. Now, I want to point out that speed is a rate of change. And we know rate of change to also mean slope. So we need to figure out what the slope is for the rabbit and the bear. And to do that, we can use our knowledge of slope-intercept form. Now, the rabbit, they said it was y equals 35x. And if I look at y equals mx plus b, for rate of change, I want my m, because it's my slope. So the rabbit is going a speed of 35. Now for the bear, we're going to have to look at the graph. And we're going to go ahead and write this as an equation just so we can practice it. But what we really need to figure out is what is the rate of change. What I see is that the bear has a slope of 3 over 1, or 30 miles per hour. Notice that it crosses at the origin, so its b would equal 0. So its equation would be y equals 30x. The two pieces I need, though, are the 30 and the 35. So this tells me that the rabbit is faster, and that is because well, it has a steeper or faster slope. Here is an equation in slope-intercept form. And we're going to go ahead and write that. I apologize. We're going to actually state what the slope is equal to and what the y-intercept is equal to. To help us, let's recall y equals mx plus b, where m is the slope and B is the y-intercept. So looking over here, M, which is the piece attached to the x, is 2/3. And then my B, my y-intercept, now I want to point out that it's -4. And the reason why is if we look back at the equation, it is always plus. In order for it to say -4, that means it added a -4 onto the equation. And when we add by a negative, it simply becomes subtraction. Given this graph, we're going to go ahead and piece together what the slope-intercept form is. Now what I'm going to do is I'm going to write y equals mx plus b. And then I'm going to go back and actually erase the b and the m and put a blank there. And we'll fill that in with the numbers as we get them. I look on the graph and I see that my line crosses the y-axis here. And that is from the origin 1, 2, 3, 4 spaces. So they were right when they said that the y-intercept is 4. Again, the y-intercept is my b, so 4 is going to go in this blank. And then I have my slope. It shows that my slope has a rise of 1 and a run of 2. But something to be careful of is when they counted that, their rise, they counted down. And when we count down, it is a negative number. So my rise over run is -1/2. And this makes the equation y equals -1/2 x plus 4. Now we're going to look at how do you put slope-intercept form on the graph. And the steps are onto the right side. You'll want to copy these down. First, we're going to identify and graph the y-intercept, which is going to be an ordered pair of 0, b. So let's go ahead and do that and look at our graph. Now remember, b is that y-intercept, so I'm going to look at the number at the end of my equation. That's this -5. So since b equals -5, I need to graph the point of 0, -5. I start at the origin. My x is 0, so I do not move left to right. But my y is -5, so I move down and put a dot at -5. So that was my b. Next, I'm going to go ahead and find the slope. Now the slope is 4/5. That is my rise and my run. And what I need to ask is, when I am counting on a graph and I count up, it's positive. Well, my rise number is +4, so that means I'm actually going to count up 4 spaces. Once I count up 4 spaces, I'm going to look at my run. My run is positive, so I'm actually going to count to the right 5. And here's how that's going to look. I'm going to start at B. So I start counting at the y-intercept, and I count 1, 2, 3, 4 spaces, and then 1, 2, 3, for 5 spaces over, and I get my point. I'm going to leave on there how I counted. I'm going to try to put another point on the graph. So I'm going to repeat step 2. Only this time, I want you to start at the point I left off at and then count. 1, 2, 3, 4. 1, 2, 3, 4, and 5, giving me my third point. The very last step is to go ahead and draw our line. And we are asking, because as you move forward, you'll be asked to do this again, that you make your lines as straight as possible, and they need to, at the very least, touch the edge of the graph. And you put arrows on the end. We put arrows on the end because graphs of lines go on infinitely. It will continue to go in that direction in a constant rate. Let's look at a second example of this. Y equals negative 2/5 x. So first, we're going to find our y-intercept. Now there's a problem. There's nothing at the end of my equation. When there's nothing written there, that means there is a plus 0. That means my b is 0, so I need to put my first point at the origin. Next, I'll do my slope, rise over run, and we need to be careful. So there was a note in the earlier steps that states if there's a negative slope, we're going to make the numerator that negative. So even though it says negative 2/5, we're going to say that the negative is on the 2. For my rise, my up and down, if I'm going to count negative, I'm going to count down. And then for my run, it's positive 5. I will count to the right. Starting at the origin, I count down 1, 2, and then 1, 2, 3, 4, and 5, and put a point there. I'll put another point. 1, 2, I'm sorry, I almost counted too far. Back up. 1, 2, and then 1, 2, 3, 4, and 5. I have 3 points, but there is a possibility where you might have to count the opposite direction in order to put a point on the graph. If you need to do that, you simply count in the opposite direction. And we'll see examples of that in class. I'm going to go ahead and put my line on the graph all the way to the edge, and then put arrows on the end. That concludes slope-intercept form.